Hi, this quick video will show you how to use the assessment tool to assess probability distributions. This is particularly useful for people who don't think in probabilities and also for those who do because it gives a visual environment to assess what we know about the universe around us. So we start by talking about or specifying the distribution on a particular distinction. So what's that distinction? So here, for instance, we are interested in assessing a distribution on the weight of a chair that's in front of us. So for this exercise to make sense, I suggest that you try this with a chair in front of you and see how it turns out. All right, so for a chair that I'm currently looking at, I need to specify the minimum weight, the maximum weight, and the units. Now the default has been set to 200. Now I know for sure that the chair I'm looking at, it cannot be above 50 kilos. So I'm going to set it from 0 to 50. The important thing to remember about this range is if the weight of the chair is outside this range, we are willing to be shocked. That's how sure we need to be about this range. It should be pretty broad. So I'll pick 0 to 50. Now the system generates a little game for us. It says, well, you can either bet that the weight of the chair is over 45 kilograms, and if you win, if this happens, you get $2 billion, or the wheel here lands orange. Okay, this game is free, and I can either bet on the weight of the chair being above 45 kilos or the wheel here landing orange. I would pick the wheel because I don't think the chair I'm looking at is above 45 kilos. What about now? Well, there's less orange, so I need to think about this deal again. Do I have a better chance of winning if this wheel is spun and lands orange, or do I have a better chance if the weight of the chair is above 45 kilos? I think I'll still pick the wheel. Maybe now, maybe at this point I'm indifferent. Alright, then I have another bet. I go to the second question, which is, now I can bet on the weight of the chair being below 5 kilos or the wheel landing orange. I'm pretty sure it's not going to be below 5 kilos, so I'm going to bet on the wheel landing orange again and again. Maybe somewhere here. Alright, I'm indifferent here. Third question. The weight of the chair is above 37.5 kilos. Or the wheel lands orange. I think I'll pick orange. Not sure if I would go any further than that. Maybe I'll leave it here. Fourth question. Weight of the chair being below 12.5 kilos. I don't think so. I think it's a little above, but I'll probably leave it at this. Fifth question. Being above 30 kilos. I don't think so, but now I'd bet on the weight of the chair. At this point, I think I'm indifferent. Sixth question, below 20 kilos. I think it's about around 20 kilos. Maybe a little more. I'd bet on the wheel now. Maybe somewhere around here. I'd be indifferent. Alright, let me go to the plot and see what happened here. So as I was making these assessments, these were being filled out. So I'm going to click on next and see what it does. Oh, look at that. So the system has generated a probability distribution, which is has been open sourced for us, courtesy of Gillian Reed's partners. What this is showing us is that this probability distribution, the area under the curve, will sum to 1, and it's sort of the best fit. And what we get here is a discretized version of this distribution. So at the level of high, which is 25% chance that it's really high, we can place it at 41 kilos. There's a 50% chance, the medium case, that it's about 20, and there's a 25% chance it's about 8. That's how we would discretize it. Now, of course, we can. The neat thing about these distributions is you can check, is this really what I mean to communicate? And what this is saying is, I'm pretty sure there's a high chance that it's above 20, but then there's sort of a longish kind of a spread. Now, that's not true because I know that the chance of this being above 35 is really low. So let me come in here. So 37.5. So I need to increase this. Instead of an 87.5% chance that it's below 37.5, I am going to make it a 95% chance. And for 45, maybe a 98% chance. Let's see what happens now. Okay, a lot better. But I am more sure that it's below 30 and 35. I mean, I want this to be not so wide because I'm pretty sure it's below 30. Okay. So then if it's below 30, I need to increase this. Maybe I'll make this 80% chance that it's below 30. Okay, there, it's getting there. Maybe there should be a 90%. Let's see what that does. So you can kind of see how these distributions should be used. I'm in real time changing my assessments to match what I mean. 95, but this is getting smaller, so the chance that it's above 35 is now the area under this part of the curve, which is good. That's basically shown to us from here as well. From here, let me make it quite steep on that end. So let's make this 90, 98, 99. Nice. So you can kind of see that. I really think it's in this part of the curve, which is really true. Also, I don't really think there's a 5% chance it's below 3. I think it's more like a 1% chance. Oh, what happened there? It jumped up. Let me try to... Oh, I made a mistake here. So this should not be... this is actually a 3% chance that it's below 5. I read it the wrong way. I don't think there's a 3% chance. I think it's more like a 1% chance it's below 5. Yeah, that's better. So this part is now collapsing. Before, note that to compare, this was 3.125. Before it was like this, and I've reduced it now to this. Maybe there's an even smaller chance. Maybe there's a 0.05 chance. Let's see what that does. Okay, better. 12.5. I'm pretty sure it's not a 25% chance that it's below 12.5. I think it's more like maybe a 5% chance. I'm really off. Better. There's a 50% chance below 20. No, I don't think so. I think there's an 80% chance. It's very close to 20. So not 80, maybe 65% chance. Could be around that range. Okay, now see, as I'm having this conversation, this is what the analyst will be doing if he or she's helping a decision maker. But as I have this conversation with myself and notice that the discretized distribution has also changed. So now it ranges from 12 to 31, which is about right. I think this is the range, the right range that I meant to communicate. So this, in summary, shows the process of the conversation to elicit probability distributions. Thank you so much for watching, and please have fun with this tool.